in x direction, then it is obvious that this operator will commute with the Hamiltonian of the hydrogen atom problem shown here. Okay, it is not very difficult to see. So I am saying that this Hamiltonian commutes with the linear momentum operator. It essentially tells you that physically that uncertainty in energy and in the linear momentum cannot be simultaneously zero, or in other words, momentum does not have a precise value. Okay. Now, if I write down, this is just a simple example. If I write down the Hamiltonian in the spherical polar coordinate, you don't need to remember this. You should remember this. There is nothing to remember. Very easy to write in Cartesian coordinate. Spherical polar coordinate is very not easy to remember for most of you. So I don't expect you to remember, but if you write it down, it will be something like this. Okay, and see one thing, that if I see carefully, if I concentrate on say this part of the operator, can you see anything special about this part of the operator? No.
This is the angular part which
Yeah.
and phi.
Yes. Yeah. There is no R dependent. Okay. No R dependence. Very simple, isn't it? And I'm going to call this operator, say, let us call it something, say A. So what I have here, I have a Hamiltonian, which is, I'm not going to write it again. This is the R part plus A over R square minus, is it fine? Okay, is it fine? Because I am very lazy, I'm not writing it again. This part will come here. This one will come here. Okay. I hope you have no problem with this. Not very difficult. Is it fine? Tell me. Write in the chat box.
Yes, sir.
Yeah, at least one. Yeah, very simple. So now if I ask you to calculate this commutator H, A, what will be the answer? Even without doing the math, you can tell me what is the answer. The answer is, this is 0, because H will commute with A. Why? It's not very difficult to see, because the H has this part, which is R dependent part, plus A divided by R square minus this. Now A, when I write the commutator of H with A will commute with the R part, because A has no R dependence. A will commute with itself. Here, also commute with this part, R. So A will always commute with the Hamiltonian of hydrogen atom. Is it clear? It's not very difficult. Very simple. Because what is this? This is nothing but HA minus AH. This is how it is. So obviously, and when I write down this H has this, what? Some R part plus A divided by R square, then some 1 over R. Okay, I am not writing other quantities. So now if this part will always commute with A, isn't it? Because this part will commute with A, this part will commute with A, and A will commute with itself, isn't it? Because this I can split it into 3 parts. So I'll have one part something like the R part of the Hamiltonian H, comma A, plus A by R square, comma A, minus or minus or plus, isn't it? So all of them are going to be 0. I think it is not very difficult. So your Hamiltonian will commute with this operator. So maybe this operator is related to some physical observable. Uh, represents, we'll see later. Okay. So now let us do something else. Let us go back to your classical mechanics, little bit of classical mechanics. Okay. Now you can think of that your nucleus is here, but think classically. This is your electron, which is revolving around your nucleus. Okay. And then this vector which joins your electron to the nucleus, this is your radial vector r. And at any instant I have this, but then I can draw another vector. This is what? This is your velocity or the momentum vector. So in classical mechanics, I can define. So since I'm doing classical mechanics to begin with, or I can define something like L. How many of you know this L? This is called. It is a cross product of r and the linear momentum p. This is a name. This is called what? This is called
angular momentum.
Angular momentum. This is angular momentum. Fine. So it is a cross product. Of course, it is a vector. It has a magnitude as well as it has a direction. So I can actually calculate this angular momentum. How to do it? So I hope you have done it in your. So for example, if I have a circular path, what is the value? Class 12 physics. A will be given by, I don't remember. So isn't it? It was M V R. Remember this? The circular path, the magnitude of L. For example, if I put the magnitude of L, then it's actually MVR. If it is on a circular path, but it may not be on a circular path. It could be on an elliptical path. So let us do it in general. So in general means the radial vector. Please unmute yourself. Don't unmute noise. So somebody has to mute yourself. Yes. So the radial vector, I can write it as a sum of 3 components. So I can write I. This is not the imaginary I. This is the unit vector along x. I x plus jy plus kz. Okay. Similarly, the p I can write as I. P I can write it as IPX JPY. Now, how many of you remember how to write the cross product of these two vectors? You remember or you don't?
Yes, sir, I have.
So matrix by matrix.
Yeah, you have to write like this. This is nothing but a determinant, which is going to be I, J, K, and you have X, Y, Z, Px, Cy, Z. So now the next thing would be to expand the determinant. So if I expand the determinant, now remember that L is also a vector. So L, I should also be able to write it as I Lx plus J Ly plus K Lz. Okay. So now when I expand the determinant, what I'm going to get, the first term I'm going to get I. Again, this I is not your imaginary I. This is the unit vector along X. I times, you know, that is ypz minus zpy. Okay. Plus J. Now the order, you remember what is the order? The first one is like this. Second one is going to be, can anyone tell me?
ZP.
Can anyone? Yes, tell me.
ZPX minus XPZ.
Yes. So it should be the other way, isn't it? Yeah. ZPX minus XPZ plus K, and you know what is this? This is XPY minus YPX. And now I can compare these two. If I compare these two, what I can see? I can see actually you can express your Lx, Ly, Lz in terms of X, Y, Z and Px, Py, Pz. So this is you're going to be your Lx. What about this? This is your Ly. What about this?
LZ.
See one thing, there are two things you should know. Whenever I write Lx, when I express Lx in terms of X, Y, Z and Px, Py, Pz, it does not contain X and Y. Sorry, it does not contain X, any X or Px. Similarly, Ly does not contain any Y or Py. Similarly, Z does not contain any Z or Pz. And why this is so? This is because this angular momentum vector, I don't know if you can see me. So the angular momentum vector, if you go back to kind classical mechanics, you see that the cross product between these two vectors will be perpendicular to this plane. It will be facing you, isn't it? Because of that, you see. And also there is an order. If it is Px, Lx, then it is like Yz. If it is Ly, then it is Zx. If it is Z, then it is Xy. So as if you have X, Y, and Z, and this is the order, not the other way. So you remember that X to Y, Y to Z. When you express Z, it has to start as X Py, Y Px. If it is Lx, then it is Y Pz, Z Py. Just check this, okay? Small trick to remember. So this is perpendicular to the plane. I can write it down. I think many of you knew about it, no? Maybe one assignment problem was there, no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Okay. So I am done with this. Now let us do a little bit of quantum mechanics because the course is on quantum mechanics. So when I go back to quantum mechanics, I should have operators for this angular momentum components. Okay. So let us define this operator Lx. Okay, Lx cap. This will be Y Z minus Z Py. Okay, all will with cap, isn't it? The operator. We're dealing with operator in quantum mechanics. Now, what will be the answer? It is very easy because you know Px, Py, Pz. No, what are Px, Py, Pz? Px is minus IH cross del X. What
Del
about
by del.
Qi? Yes, I write it down one more time. I hope everybody remember. Everybody remembers everyone should know at least about it. Anyway, so minus IH cross is common. So what I can do, I can take this minus, so maybe I'll change the color. So I can take this minus IH cross outside. If I take this minus IH cross outside, what I'm going to get? I'm going to get Y del Z minus Z del Y. Is it clear? So this is your x component of the angular momentum operator. Okay, so I'm writing it again. This is fine. Similarly, I can define Ly and Lz. So basically, what you have is Lx is this. So similarly, you can define Ly. Ly is not very difficult. Ly is going to be, you know, Z x del x minus x del z. Okay. Similarly, Lz is minus Ix cross. Now I should write yes. So it is x del y to y del x. For CH812, there was a question. One more question, I think. The question was justify or contradict whether the total angular momentum in case of hydrogen atom is conserved or not. I don't think anyone could answer that question because this is,
it will be conserved.
yeah, this was CH812. Because people did not listen to my recorded video. It was from that recorded video, and it is in quantum mechanics as well as in classical mechanics. People actually, what happened that you had problem with two terms. One is conservation, another one is quantization. Quantization of the energy for the angular motion is not the conservation of angular momentum. That you have to know. What do you mean by conservation of angular momentum? I'll do it here. So my L is R cross P. Now conservation of angular momentum, in other words, it is called that angular momentum is a constant of motion. Some of you would know this language or this phrase. Okay, which basically means if I take a derivative of the angular momentum, then the derivative of angular momentum with time is 0. So the total angular momentum does not change with time. So as a result, total angular momentum is conserved. Okay, and this comes because your system, your problem has spherical symmetry. It is a case of central force or central field problem. If you see the recorded video, I think you guys did not watch my recorded video. If you want to really learn, please watch recorded video. Okay, this course is for learning, not for getting only some grades. So L is equal to R cross P. So now if I take a time derivative of this L, angular momentum with time, what is I'm going to get is a product of two. So I know I'm going to get dr dt cross P plus R cross dp dt. Now what is dr dt? Dr dt is velocity, no? Velocity vector. What is that?
Yes.
That is momentum vector divided by mass. This is fine. Okay. So what about this term? Tell me. What about this term? The first term. Is it okay if I write? So what is this? I hope everyone is following. This is
P square by M.
Yeah, it is V cross P, isn't it? V cross P. Fine. Which is? Tell me. The 1 over A, maybe the constant, does not matter. P cross P. Now you go to your class 12 vector. If I take a if I take a scalar, sorry, the cross product of a vector with itself, what is the answer?
0.
0. You know that because the angle between these two is 0. So sine 0 is 0. You remember? P cross P would be like P magnitude sine theta. Remember? Remember that. And theta is 90. So if I take a cross product of a vector with itself, it is 0. So what is happening to this term? This term is 0. It is not very difficult. Huh? Fine? Very easy. Just your school, class 11, 12.
Sir, we can do it with an alternative method as well. We can say it's a central force problem,
Yeah,
so
yeah.
torque will be 0 on the system.
Okay.
Angular momentum will be
Okay, let me tell you. I'm going to use the central force problem here. What about this guy? R cross. Now rate of change of momentum. You know what is that? Newton equation. This is R cross force. Okay. Now I'm coming to Devojit's answer. This force, we are doing a central force problem. No, what should I write? Central field or central force problem. No. What does it mean? F is a function of R and it is along the radial direction, isn't it? What does it mean? See here, the radial vector is like this and the force is also along the radial direction. So what will be the cross product of this? What will be the cross product of this? Tell me. If you have a vector,
0.
and
0.
then you take a cross product of that vector with another vector which is along the same vector. It will be 0. It's not very easy. It is class 11, 12 physics. You are doing chemistry does not mean you'll forget all the physics. Okay. You are not an expert in physics, but little bit of physics everybody has to know. So then what is the answer? The answer to this dl dt is what? 0 plus 0 is 0. What does it mean? It means that, what should I write? Sorry, I have no, you say that is conserved. Okay? For any central force problem or central field problem, what I'm going to call it, and there was spherical symmetry in this particular case, and it is conserved, or in other words, this angular momentum is constant of motion. Okay, so Devojit, this makes you happy?
Yes.
Yeah.
Why I would be happy?
Huh? What?
Why I'd be happy?
No, you're not happy. You look like that you like some other method. I don't know. Anyway, so this is, you should know. See, nobody is going to tell you, and unless you read physics books, you never learn. I'm telling you. It is getting recorded. I don't know. But please read things from physics books if you want to really learn the subject. Anyway, so after that,
Sir,
it's fine. Yes.
uh,
Tell me.
if it commute with Hamiltonian, so also it will be conserved.
Yeah. I'm coming to that. Okay. You have a lot of noise in your background. Okay. Let me continue. Okay. Because I have to do many things today. Okay. Yeah. You're right. Yeah. So your L square. Okay. Now I should actually put this. Then I think then square and then cap. I'm very particular. So this is, you know, this is I'm going to go a little fast because I want to cover few things. This is fine, na? L square plus Ly square plus Lz square of the total angular momentum. So if I now ask you to calculate, before you calculate that, let us try to calculate this commutator Lx, Ly. What is the answer?
Yes, Carl Alzad.
You guys remember, mug up all the things, you mug it up and remember. So your answer should be, sir, this is not going to be 0. If you tell me the answer, IH cross LZ, whatever. Okay. Yeah, it is not 0. Basically, Lx and Ly do not commute. But let us show that they don't commute. What is the expression for Lx? Let me write it down fast, because if I do anything wrong, please tell me. Ly is, okay, y means x by z. This is fine. The expressions. So if I write down Lx,
Yes, sir.
Lx, Ly, the commutator, which basically means Lx Ly minus Ly Lx, isn't it? So this will give me minus IH cross square, isn't it? Because I have to multiply Lx with Ly, so that will give you IH cross whole square with minus, yeah. And Lx Ly minus Ly Lx, isn't it? So and let us operate this on a function f. Let us operate this on a function f. Okay, some function of x by f. You can call it psi if you want. Phi, I don't care. So minus IH cross will come out, and what I have here is the first term is going to be y del z minus z del y into z del x minus x del z minus, now the order should change. It is important, Devojit and others, please keep an eye. The high probability I'll do a mistake. If I do it on a board, it is easier for me. It is always difficult if you do it using this tablet. It's fine. Up to this fine, I think, sure.
Yes, sir.
So let us do the first thing, Lx into Ly. Yes. Okay. So Lx into Ly, and that will operate on x. Okay. So the first term is y del z into z del x operating on f. Okay. So let us write it down. Y del z into z del x on f. This is fine? Is this fine? Okay. And next I have a term like this into this, which basically give me y del z x del z into f. And next will be plus z del y z del x into f, and the other one would be like again plus z del y x del z into f, like f. I'll have 4 more terms which I'll do later. Okay, first let us do Lx into Ly operating on f. Now what about the first term? Tell me. I am doing it because very important. Once I do it, you know how to do this operator thing. What about this term? Look at it. I have a derivative with respect to z, and that will operate on the whole thing, z into del f del x, isn't it? So this will give me what? This will give me y.
So there will be a negative sign on the third.
Okay, third.
Third
Okay,
component.
this one into this one is plus, this one into minus, this one into plus, this one into minus. Yes, you're right. This one, the fourth one. Talking about fourth one or the third one?
Third one.
No,
Third one.
the third
Yeah.
one.
Yeah. So, okay, very good. Now, what about this guy? Tell me. Now, del del z operating on this. So, this will give me y times, you just see very carefully, del f del x. This will be one term. Is it fine? What will be the another term? It will give also another term. It will give you plus yz into second derivative of f with respect to del z del x. Fine? Is this fine? This is from this. Okay. So this is something like this. So from this part, what I'm going to get? I'm going to get y. Okay, minus. You put minus y. Now yx del 2f del z square. I think I'm get only one term because the other term will be 0, isn't it? Okay, is it fine? Is it fine? If you have any problem, tell me. If you have any problem, please tell me. Okay, because del x.
Sir, can you please repeat?
Yeah, because
How the
when
second term is coming?
del x when operates on x times del f del z, first I take x outside, I operate del z on this, which will give you this. Next term will be I will operate del x on this x, which will give me 0. So next term will be 0. The product of two functions, no, x and this. They are operating del z on product of two functions. One is x, other one is del f del z. So that's why it is. I want to get this. Not very difficult. You have to practice a little bit. See, cannot do this course without doing little bit of math. Okay. What about the next one? This one. This one. If I am doing any mistake, please, Arko Prabhu, whatever, Devojit, anyone, tell me. This will give me z. Again, it will give me z and then what? Z square actually, because and then del 2f del y del x. Will I have any other term here? Will I have any other term here?
No, sir.
No, because the next term will be 0.
Yes.
Because when I operate del y on z is 0. What about this guy? This guy will give you plus z. Sorry, don't need to write plus. If there is nothing, this means plus. Yeah. So then again, it is zx del 2f del y del z. Any other term? I don't think so. Huh? I don't think any other term. Fine, no? So again,
Yes, sir.
same problem. So now I have got first 4 terms. So now I have to do the other thing. So I have to go back and do this thing. So what I'm going to do now. So let me put a second bracket here. Minus second bracket, curly bracket, and then I do this thing. So what is the first term? Z del x, y del z, isn't it? So it's z. Okay. Just wait for a second. It is z del x, y, first term. Forget about this minus because minus I'm taking outside. The next term will be minus z del x, z, then minus x del z, y del z, plus x del z, z. Okay. Any problem with the sign or anything? Tell me. Hope you are following. Any problem with the sign or anything? I don't think so. Again, now I'm going to simplify these things. So let us simplify. So what about this? This one. What I'm going to get here? Tell me. I'm going to get z
ZY.
zy del 2f del x del z. Okay. But again, I have a minus sign. I'm now including the minus sign. If I include the minus sign, I'll get minus. Fine. What about this? First of all, this minus and minus will give me plus. Okay, that is good. Then I'll have a term like z square del 2f del x del y. What about this term? This term again, minus and minus will give me plus, so it will be x y. What I have not written, you should have told me. Sir, you have forgotten to write this. You guys sitting, no? I should not forget. Okay, yeah. So this term will give me del lxy del 2f del z square. What about this guy? This part will give me minus x. Now look at carefully. I'll have two terms here, minus x del f del y minus x z del 2f del z del y. Please tell me if I have done anything wrong. Please tell me. Yojit, are you there or sleeping?
Yes.
Yes.
Yes, sir.
Yeah, I think it's fine now. Like I should not be doing anything wrong. Okay. So now let us try to. Any problem?
Sir, last term, sir, minus is there, plus will come.
Yeah, plus three negatives cannot be there.
Which one? Last term.
Yes, sir.
Yeah.
This plus and this minus, no? That will give minus. Yojit?
No, sir, that's fine, I think.
Yeah, you have
that's
this
fine,
plus
sir.
and this minus. Minus is outside. Now I put it outside initially. So this time that's why it has become minus. This has become plus. This has again become plus. So this should become minus. This one.
Yes,
as well.
yes, sir.
Yeah.
Correct.
So let us now see whether we can actually make the thing simpler. You can, because for example, you look at this term z square del 2f del y del x. What is this? This is z square del 2f del x del y. Del x del y and del y del x doesn't matter what order you do, but the signs are different. This term and this term. Can you see? So adding, no? So what I can do? Cancel. It is fine. Yeah.
Yes, sir.
What about this guy? yz del 2f del z del x. This is with minus yz or zy, doesn't matter. Del 2f del x del z. What should I do? I should cancel. What about any other cancellation? Can I cancel anything? What about this guy? xz del 2f del y del z. xz del 2f del z del y. What should I do? I cancel. What about this? yx del 2f del z square. What is this? Same, no? This is minus, this is plus. What should I do then? Cancel. So what I have left to it? How many terms we have? We have only two terms. See, this one and this one. Can you see this? This two? So let me write it down then. I hope you are following. It is not very difficult. What I have here is y del x minus x del y. Yes, I can outside. But again, I can do one thing, because you remember that I had an expression for Lz. What was Lz? Just minus IH cross x del z. Okay. Okay. Not del z. It is del x. You should tell me. Del y, yeah.
Y.
Del y minus y del x. You see, I have already got it. Yes. So I'll just manipulate this. What I'm going to do, I have minus I cross per whole. So what I'm going to do, I'm going to multiply with minus 1 the whole thing. Okay. So I have multiplied with minus 1. I keep minus IH cross here. Okay. And minus IH cross here. And then I change the order because I multiplied with minus 1. It will be x del y minus y del x. Okay. Now what is this? What is
LZ.
this? Tell me. This is your LZ. And what about this? This is, what is this? I into minus 1. Minus I into minus 1 is I H cross. So what I have here? Is the commutator of Lx with Ly is nothing but I H cross Lz. And this is a very important relation. And you have physical significance for this as well. If two operators commute, which basically means the observable associated with these two operators can be measured simultaneously, isn't it? Both can be measured simultaneously with precision. Okay. So now let us, actually it is not very difficult to show that since Lx and Ly do not commute, it's possible to show that if I go to not only Lx, Ly, you have Lx, Ly is IH cross Lz, then what will be, say, Lx, Lz? Can anyone tell me? This is IH cross Ly. Fine? Is it fine
It
or
should be
not?
minus
sir,
iota.
it should be minus.
Yes.
Minus
It is
iota.
minus. So that's why I said that it's minus. Minus. Why? Why minus? Can anyone tell me? Because I'll never write in the order x, z. I can write, then minus will come.
Cyclicity has to follow.
Yeah. So one has to write like this: Lz Lx equal to IH cross Ly. Remember this one: x, y, z. The order is like that. Okay. The order. This is a trick to remember. So similarly, I can also do something like say x, y I have done, z, x I have done. So basically y, z. If I do y, z, what I'm going to get? This is
IH cut LX.
Okay. So these are the relations you should know, and you know. Now let us do this thing. If I calculate L square with Lx, say, yeah, or Lz, let us do it with Lz. What is the answer? So let us do it. L square means Lx square plus Ly square plus Lz square into Lz. So I'll have something like The commutator I can split. I can write like this. This is fine. I hope you understand if I write like this. Sorry. This is fine. I hope this is fine. If it is not fine, tell me. It's not very difficult. It's very easy, no? If I have an operator A, say A plus B, comma C, the commutator of this. What is this? This is nothing but A comma C commutator plus B comma C commutator. It's very easy to see. So this is exactly what I have done here. So if I do this, what about Lx Lz? Tell me what is Lx Lz?
Lx
Or is
square
Lx
should be
square?
given.
Square, yeah. Now let us calculate this quantities. So I am going to now calculate all these quantities. Okay. So let us calculate this. Lx square Lz. If I expand, what I'm going to get? Lx square Lz minus Lz to Lx square. Fine. Okay. Now I'm going to do a trick. I am going to add something and subtract the same thing. On this, I add. See, I am adding something and subtracting something. What I'm going to add? I'm going to Lz, not Lz, Lx. What I'm going to add? I'm going to add Lx into Lz into Lx. If I add this, okay, then I have to subtract this as well, no? Sorry. I'm adding this. So I have to subtract the same thing. So I should also have plus. This is a trick. I'm telling you. Lx, Lz, Lx minus Lz, Lx square. Does it help? It helps because now I can take Lx common from left, not Lx square, Lx. If I take Lx common from left, what I'm going to get here inside, I have Lx, Lz minus Lz, Lx. Okay, so this Lx and one of the Lx will come out. You get Lx, Lz minus Lz, Lx. What about the next term? Next time I'll take common. I'll take common from the right. What I have here is Lx. What will I have here? Tell me. I'll have Lx, Lz minus Lz, Lx. Okay, it's fine. What about this?
Yes, sir.
Yeah, it is not very difficult. What about this? What about this? Do you know the answer to this? Lx, Lz, I told you. It is nothing but the
Lx comma
commutator
Lz.
of, yeah, which is minus IH cross Ly, isn't it? This will be minus IH cross Ly. What about this? What about this? Tell me. The same thing, no? Okay. So what I have here is, I can just write it down. No, is it the same or it is? No, it is xz and is it? Have I done anything wrong? Please check. I hope I have not done. I have just added Lx, Lz, Lx. Yes. and then added Lx, Lz, Lx, okay, and Lx, Lz. I think this is fine, no? Is it fine or not? Tell me if I have done anything
Yes,
wrong.
sir. It is correct.
It is correct, no? Devojit, I
Yes.
hope I have not done
Yes, sir.
anything wrong. Lx, Ly, plus Ly, Lx. Like this, no? This is what I get. I should get this. Okay. And then you can also do this Ly square Lz. Now, first of all, Lz square Lz, what is the answer? This one is very easy.
Zero.
What is the answer?
Zero.
0.
0. And whenever I do Ly square Lz, what I'm going to get? I get Ly square Lz. So I do this, what I'm going to get? I'm going to get the same thing I can do. This is essentially Ly square Lz minus Lz Ly square, and then I add something and subtract the same thing. What I add is Ly, Lz, Ly, and then I do Ly, Lz, Ly minus Lz, Ly square. What I'm going to get here? If I take Ly common, I'm going to get Ly, Lz minus Lz, Ly plus Ly, Lz minus Lz, Ly into Ly. What about this again? What about this? This one is, now YZ means this is IH cross LX. What about this? IH cross LX. So what I have here is IH cross, and take common, Ly Lx plus Lx Ly. And now if I add, so this is 1 and this is 2. If I do 1 plus 2, what I'm going to get? What is the answer? So basically this one plus this one, this will give me what? Tell me. It will give me minus.
0.
Yeah, it is 0. So essentially what I have here is, we have proved that, okay, that L square with Lz is 0. If I have a commutator of L square with Lz, 0. Actually, there is nothing special about x and y and z. In spherical polar coordinate, I will say the angle is theta with the z axis. But other than that, you have spherical symmetry. So x, y, z, they are actually equivalent. There's nothing special. So it is also possible to show. I'm not going to show actually. If you take L square with Lx, what do you expect? What is the expectation?
0.
Tell me.
0.
Yeah. So you can go and check that they're also 0. Okay. So now after this, I think we have done it, but now I'm going back to the hydrogen atom problem. And this is very important. Next half an hour is going to be very important because, and I'll do it very fast because you write down the Hamiltonian for hydrogen atom problem. I think it is here. So let us Hamiltonian, no?
Sir?
Yes.
Sir, can we actually use the property of the commutator to evaluate the previous two things, commutator relations, like the Lx square Ly? If we take the Lx outside in the left hand side and add it Lx Ly and again Lx on the right hand side.
Yeah, you can do it. I don't know what exactly you're saying, but you can do it. Maybe we'll talk after I'm to finish this. Okay, let
Sure.
me continue. We'll talk later after the session. Okay, so this is a Hamiltonian for the Harvey-Norton problem. This you know. Huh? And actually, if you do the algebra, which you have not done, going from x, y, z to r, theta, phi, it is possible that actually you show that the angular square of the angular momentum operator L square
The minus h square by 2 mu term is missing.
operator, yeah, right. Operator for the square of the angular momentum. Okay, so this is operator, and okay, what is missing is minus h cross square by twice. Then okay, just write it. Okay, minus is there. And this one, if you do the algebra, I'm not going to do it. If you do the algebra, you will see this is nothing but h cross s square 1 by sine theta del theta sine theta. This I don't expect you to remember, but if you do the algebra, you'll get it. It's exactly like. Okay, you can do it. So if I know this, then I can write down the Hamiltonian in slightly different fashion. What will be the way I'm going to write it? I'm going to write it like this. My Hamiltonian is going to be minus h cross s square by twice mu. Then you have this radial part. Let me write down the radial part. 1 over r square del r square del r. Okay, this radial part. And then I have to multiply it with minus h cross s square by twice mu. So let us do it. Minus h cross s square by twice mu r square. Okay, and then the whole thing. But look at it. This minus h cross s square, the whole thing is L square. Minus h cross s square by the whole thing is the L square. So what should I do? I can just write it as just by from the above equation. I can write plus will come because this minus h cross s square and this whole thing will give me L square. What I'm going to get is like sometimes I don't put it here. Okay, this L square, this is fine. This is exactly what I'm going to get, and then I'll get what? And this is now very simple. So this is what? This is the kinetic energy due to radial motion. This operator corresponds to, isn't it? This operator corresponds to kinetic energy due to radial motion. Now, if I ask you this question, now the Hamiltonian, sorry, this is the problem. Ask you this question, this Hamiltonian and L square, will they commute or not? Tell me. Will they commute or
Yes,
not?
sir.
This is 0. Because I have told you this has to commute because L square has only theta and phi. So it will commute with the radial part as well as this part and also with itself, isn't it? It will commute. So basically, and nothing, since nothing is special about, and we had already shown that L square commute with Lz. It basically means your H will also commute with Lz. So essentially it tells you that they should have a common set of eigenfunctions, no? They should have a common set of eigenfunctions. Okay. And one more thing, if you do that, it is possible to show that if you do the algebra, that the operator for Lz, maybe you should remember this is I H cross. How many of you remember? What is this? Tell me. What is the operator for the Lz? Anyone remember? It is this. You can check. And if it is this is obvious. Look at it carefully. This Lz will commute with L square because it will commute with the theta part as well as with this part, because second derivative and first derivative, it will be the third derivative. Doesn't matter in which order you operate, you put. And also it will commute with H. Okay, these things I am not telling you, but actually you can do the algebra and show that your L square has this particular form in spherical polar coordinate. I don't expect you to remember, but it will be good if you can remember this at least. Lz is very simple. Ly, Lx, they are more complicated. Okay. Now I go back to your hydrogen atom problem again, and what I'm going to do it right now, that if you go back and see the angular part of the hydrogen atom problem, that is psi, let me write down, psi n L m is a function of r, theta and phi, is given by r, which is a function of r only, depends on nl. Then you had a function theta, remember, is a function of the angle theta. It depends on what? Tell me what it depends on. It depends on L as well as on magnitude of m. And then you had this capital phi function of small phi. This depends on m. Remember this structure. And if I combine these two, what I get is spherical harmonic, and their function of L, m, theta and phi. You can go and check your notes. Okay, is this fine? Now if I now take this operator L square, operate on this psi n L m, which is a function of r theta phi, this is equal to L square operating on r n l times y l m theta phi. But there's a catch here. What is that? RNL has no theta phi dependence. RNL has no theta phi dependence, isn't it? Please say yes at least. Somebody.
Yes.
Yes, sir.
Yeah. So what does it mean? It basically means that I can take it here. L square will not operate on this. So what I'm going to get is equivalent of saying, okay, I can put this R and L in here, and L square operate only on y, L, and theta phi. But actually, you know the answer to this problem. How? How do you know? Because if you recall that we had also written the Schrodinger equation for the hydrogen atom problem in the in a slightly different manner, and for the theta phi part, it was something like 1 over. Go and check your note. Remember this? At least you should remember that the m square was there. Remember? The whole thing was operating on theta part gives you 0, Also, you had another equation like the problem. Yes, go and check. It was like this. Okay, and it is not difficult to show, not difficult to derive or show. But I'm going to write. I'm not going to show it exactly. Just a little bit of algebra here. If you do that, if I take this L square operator operates on this y lm theta phi part, if you do it, you will see what I'm going to get. What I'm going to get is L into L plus 1 into h plus h square y lm theta phi. Basically, you have an eigenvalue equation. Okay. So what you have is an eigenvalue equation for L square operating on y, the spherical harmonic. And what is this? This is the eigenvalue. And if I take this quantity, this gives you, so L square is a vector. So
Orbital angular momentum.
yeah, this will give me something like the length of the vector, length of the magnitude. Of angular momentum. So what is this? This is root over L into L plus 1 into h cross. And these are the actually values of orbital angular momentum. Okay. These are called. What is the value for s orbital? What is the value for the s orbital?
H cut.
S orbital
Zero.
A is 0. So the value is 0. Okay. This is fine. So let us do it in the next class. Not next class, in the next slide. But before we do this, let me tell you one more thing, small thing, that actually you can now do Lz also. As I told you that Lz is given by minus AH cross first derivative of respect to phi. And you remember what is the expression for phi m? I'm writing down. Not very difficult to remember this one, no? So if I now do Lz on this phi m, phi, what is the answer? 1 by root over twice phi is a constant, take it out, minus IH cross, and then the del of phi of exponential of Im phi. What is the answer? The answer is minus IH cross, let us write it down, 1 over twice pi root over, and this m will come down, isn't it? M times exponential of, Im times exponential of Im phi. What is the answer? This Im and minus IH cross, if I combine, what I'm going to get? I square is minus 1 with minus this last one. So it will be MH cross into so what I have here is this Lz operating on this. This is fine, very simple, because what I have here is this. This is what we had started with. This is yours. Yes. Fine. So basically, the phi m phi is an eigenfunction of Lz operator with the eigenvalue m h cross. And what are the values of m possible? What are the values of m possible? Tell me. What are the possible values of m? Tell me.
Minus all including 0.
M is 0 plus minus 1 plus minus 2 like this. For s orbital m is 0. Okay. So now we have two equations, this one and also I had the
Sir, you are mute.
Yeah, something happened. Anyway, so okay, what I was telling, is it good that I speak like this, or can you hear me? Just
Yes, sir.
yeah. So we have two equations. So the one is here, shown here. Yes, this one, and the other one is this one, and the other one is here. It is an important thing. So let us now. So basically, one is L and another one is LZ. And you now let me draw something. For example, if I choose n equal to 1, what are the values of this quantity? The magnitude for the angular momentum, total angular momentum. What is that? What are the possible values? Can anyone tell me?
Root 2 h cut.
The first one, L equal to 1 means it is root 2 h cut. Okay. But for L equal to 1, what are the possible values of m? M are 0, 1 and minus 1, isn't it? So this, the value of this quantity, mh cross, possible values as 0, h cross, fine? So let us now draw something. Right? Let me draw something here. This is your z-axis, and this is your xy plane. And if I draw a vector, the length of this vector is L into L plus 1 h cross. And let us choose L equals to 1. Then what is the length? If you choose L equal to 1, the length is root over 2 times h cross. Is this fine? This is the length. What about mh cross? This is the projection of this onto the z-axis. That is what is the mh cross is. So when m equal to 1, the value is h cross. When m equal to 1, the value is h cross. If you project this here, so what is this value? Tell me. Tell me what is the value? Can anyone tell me, please? Unmute yourself and tell me.
H cross.
H cross.
H cut.
And when m equal to 0, same vector will be along in the xy plane. Okay, xy plane, the value will be 0, but the length will be the same. So this is the vector, but on the xy plane. What about when m equal to minus 1? When m equal to minus 1, it will have the value minus h cross, isn't it, on the other side? Okay, is it fine? But this is your y-axis. This is your z-axis. What about this commutator LZ, comma Ly? This is not equal to 0. We have shown they don't commute. So LZ, comma Ly, they don't commute. What does it mean? It means that simultaneously I cannot measure Lx and Ly, isn't it? I cannot precisely what are the values of Ly and Lz simultaneously. In this case, Ly and Lz. So essentially, it tells you that I should actually this is the value of capital L. The projection of this gives you Lz. And if I take a projection of this on the xy plane, on the y-axis it will be Ly, but they are uncertain, Lz and Ly. I cannot know Lz and Ly at the same time with precision. So as a result, I know only the projection of Lz is H cross, but I do not know what is the value of Ly. So it could be anywhere around the z-axis. Only thing is that the projection is H cross in this case. So then what I should do? I should actually draw a cone like this. And the same thing I should do on here also. No? I should also have a cone like this. Because they don't commute. And similarly, for m equal to 0 also on the xy plane, I should also have something like this. You must have seen this picture in books. And these cones and whatever the circle on xy plane, this is a flat cone on xy plane. These things come because of the fact that Ly, Lz in this case, they don't commute. Also, the z-axis is towards you because the z-axis is like this. So that's why I have to make a cone. You understand? The cone means what? On the xy plane. So if it is only Lx, only Lz and Ly not commuting, then it would have been only a 2D picture, but you have a 3D picture because Lz and Ly, Lz and Lx, they also don't commute. Okay. So as a result, I have to draw this cone because it could be, this vector could be anywhere. Only the projection of this vector on z-axis is this, but this vector could be anywhere in the x and y component of this vector could be anything. As a result, I should have a cone. The vector should have a cone like shown here. So the value of Ly and Lz could be anything. What I know, the length of the vector and the projection of the vector on the z-axis. Okay. So if I do the same thing for L equal to 2, L equal to 1 means this is P state, L equal to 2 is what? D state. For that, how many projections will be there? There will be 5 projections. You understand? Because M will vary from -2, -2, -1, 0, +1, +2. There will be like 4 cones and another cone on the xy plane, which is like a circle. Okay? Is this clear? Please tell me when it's clear.
Yes.
So I think I am going to stop here because I think I have done many things today. But this is very important what I have done today because what you can see that your H and L square they commute. As a result, they have a common eigenfunction. Your common eigenfunction is your spherical harmonic. That's your common eigenfunction. And the common eigenfunction of H and Lz is this phi part. This phi of okay. So at the same time, I know what is the value of L square and what is the value of Lz, but I do not know the value of Lx and Ly and Lz at the same time because they don't commute with each other. That is the physical significance of two operators commuting or not commuting. Okay, very important. With that, I think I'll finish today, and whatever I've taught till today is going to be in the syllabus of the mid-sem. Starting from the very first day till today, whatever being taught, so that is the syllabus for the mid-sem. And thank you very much for your attention. What I'm going to do now, I'm going to now stop sharing stop sharing.